We'll get started. So today we're talking about networking. That's the part one of networking. Next week we're gonna talk more about networking. Yeah. So we'll start with some review. The first question is, what is one reason you would use a collection view or over a table view? Yeah. What did you want to answer?
Oh, yes.
What's your name?
I'm Cameron.
Cameron. Okay. Yeah. What's your answer to this?
C.
C. Oh yeah, that's correct. You can scroll in both directions and use a grid layout. Um, Next question is, how do you set up the spacing of a collection view? Oh yeah, I think I asked you your name last week, but I mean the one. David. Okay.
Is it
B.
B?
Close but not B. Did you say A? Oh, it's not A. So, well, now the answer is obvious. It's C. When you set up the spacing, you don't set it directly for the collection view. If you remember, when you did the homework, we had to first create a collection view flow layout, and you assign the spacing to the flow layout. And later on, you attach that flow layout to the collection view. Does that make sense?
That is the minimum spacing, though, correct?
For oh well, yeah, for the minimum spacing. That's what the question meant. But
Okay.
I guess you could also like do your spacing depending on the size of the collection view. Okay. And then the overview for today is we're going to first talk about networking and then HTTP requests. How do you have how do you use libraries? And that's done with cocoapods. And then lastly, we'll talk about closures. So first, let's start talking about networking. So the idea of networking is basically just how several computers can communicate with each other and share information. And in our case, we want to use networking to, so we have our app, and we want to use networking to connect to the internet, and the internet can help with the app talking, help the app to talk to information on other computers. So, yeah, why would we want to connect our apps to the internet? So let's first look at an example. So if you look here, you have like Facebook, Gmail, Google, and all of these information like all on the internet, right? Like they're not just like there on your device. So if we were to like make this email screen, what we have done in class is first you would like have an email class, and then you will like have email 1, email 2. They may have like a title, a content, and whether it's like starred, and then you will have this array of emails that you would display in the table view, right? So yeah, you will so to make this screen, you will make an email model, and then you have an array of email objects, and then you will use the collection view or table view to show that array of data. That's how we have done it in class so far. But that's not really good, right? Because we are just manually adding all these information to display, and I'm sure you have already experienced this. Like every time, let's say for your the table view homework, every time you update your data, and then you rerun the app, right? Like everything you've made changes to is erased, and you just start it fresh again. So you're not keeping track of any changes you made or any like new information that could be added. So the way we can resolve this problem is through networking. So that way we can communicate with the internet and communicate with other computers that can store all the information you need, and you can make changes to it and then get it back. So how do we connect our apps to the internet exactly? Well, actually, is there any questions for what we talked about so far? No? Okay. So the way we connect to the internet is through HTTP requests. So basically, HTTP request is just a form to communicate between the client and the server. And for iOS development, the client would just be the mobile app we're building, and the server could be somewhere on the internet. It's like stored in some other computer. Does this make sense? Okay. So yeah, to iterate. Internet is just a global network of computers that communicate with each other. And then clients are devices or software that calls on another device. So for iOS, that would be like your iOS app. And then servers are devices or software that are called by another device. Okay. And then there are several forms of HTTP requests. The main three requests that we're going to use is get, post, and delete. So get is used to retrieve the information from the server, and then post is to send that information to the server if you want to like add some like let's say add an email or like update an email. And then delete is just to delete something, so like maybe deleting an email. And then this is an easier way to remember is just you need a way to create, retrieve, update, and delete. And then there's the acronym CRUD. Does the three HTTP requests make sense? Anyone have questions on that? Yeah.
What does CRUD stand for again?
Create, retrieve, update, and delete.
Okay.
Yeah. We're good here? Okay. And then how do we communicate with the server exactly? So we use JSON, which stands for JavaScript Object Notation. This is the format of data that we're gonna use to store and like send to the server. And JSONs are just key value pairs, very much like a dictionary. And the keys are always strings, and the values could be strings, objects, numbers, Boolean, arrays, or null. And then, so when you send some information to the server, it's usually in JSON format, and when you get information back from the server, it's also usually in the JSON format. And then we can look at an example of how a JSON looks like. So basically, it just looks like a dictionary, right? So you have like a key that's called name, with intro to iOS development, and then you also have another key called course number, it's 1998, and then you have the key instructors, and for the value for key instructor is a list of other objects, which is like the instructors, and each like each is another like dictionary inside, right? Just representing an object of instructor. Does this JSON make sense? Yeah. Anyone have questions on JSONs? Again, like this is what the format of data that we're gonna send and get from the server. So how could we make HTTP requests on our iOS apps? what we're gonna use is a library called Almofire, and this library just helps with making network requests. You can make network requests just with Swift, but with like the original like Apple way that they tell you to do, but it's really annoying. So Almofire is a library that like makes this a lot easier, and does all the dirty work for you. Um, so what exactly is a library? It's basically just a bunch of code like other people write to make your life easier. So if you're taking 1110, like you use like the turtle thing that they wrote. Yeah, so that's like a library that just has all the code written out for you and you can use in your own code. And then some examples of libraries in Swift is if you have used the Eatery app, like when usually when you open a Eatery, it has this like nice animation that like that where like the Eatery like dissolves and pops up. So that's done with this library called Hero Animation. And then on Ithaca Transit, the map, like we didn't build out the map ourselves. It's just using Google Maps library. And then there's this really nice animation library that just give you a bunch of cute animations. So, and anyone have questions about libraries? Okay. And then we'll talk about cocoapods. So cocoapods is basically a way to manage all of the libraries you're using in your project. And there are like over 45K libraries. So there's like so many. Like people put out their code like publicly for you to use. There's so many of them. So it's really nice to have that. So yeah, CocoaPods just makes managing your libraries a lot easier. This is if you use pip in Python or npm in Node.js, they're just basically like the same thing. And the way you use CocoaPods is you gotta install it on your laptop first. So the way you install it is you do sudo gem install CocoaPods. You don't have to do it now, but like you can do it at your own time. But if you want to use CocoaPod, you have to install it on your laptop first. And you do that on your terminal. Is anyone not familiar with what terminal is? Okay, you can just like search up terminal on your laptop and it opens the terminal. And you can just type this command on your terminal and it'll install. And then the way you use the CocoaPods in your own project is you will have to, on your terminal, you'll have to navigate into the folder where your project is held, and then you have to do pod init. And pod init will create this file called pod file. And then how a pod file looks like is just this is the image is an example of how the pod file looks like for course grab. So these are all like the libraries that we use. So for example, like Google Sign-In, that's one of the pods that we use. And yeah, we don't usually call it library; we call them pods. So so you would just list out all the libraries that you're gonna use in the pod file, and the way you list it out is you just say like pod and then the name of the CocoaPod, and then after you had this file on your terminal, you will have to say pod install, and then that will install all of the CocoaPod you indicated on your pod file, and then that will also create a new project, and then you will end with XC workspace. So before for our homework, we have always had a Xcode proj file, and that's where you open to like run on your Xcode. But if you're using CocoaPod, they don't work on Xcode proj, the Xcode proj file, but you have to open the XE workspace file to work with the CocoaPods. Does that make sense? You're just like using another file to open so you can run your CocoaPod. It'll probably make more sense when I demo it later. Anyone have questions? Okay. And then next we'll talk about closures. So closures, we're gonna use it a lot for networking. So it'll just be nice to know what they are. And you have an extra credit assignment for this week that's gonna be on closures. So what are closures exactly? They're basically just a block of functionality that can be passed around and used in your code. They're basically like functions, but you kind of write it differently. We can look at an example. So let's say you have a function that you want to have a function that just adds two numbers. So if you write it in the function form, you would just do func add two number. You say the function's name, and then you pass in the parameters, which is first and second, and then your return type is an int, right? And then you just do return first plus second. And then when you want to add two numbers, you would just call on add two numbers function and then pass in the first and second numbers. But with a closure, the way you set up a closure is you have these curly braces. You can look at the bottom, like the closures are usually in that form where you have the parameters you have the curly braces, and then you have the parameters in parentheses, and then you use the arrow and then indicate your return type, and then you have this in keyword, and after that in keyword you would write out whatever code chunk you wanted to run. So in the add two numbers closure case, your parameters were first and second, and then the chunk of code you wanted to execute is return first plus second. And then later you can just call, when you want to execute this closure, you would just call add two numbers closure and the 1 and 2 as your parameter. Does that make sense? It's just a different way of writing out your function. Okay. And we'll look at a more concrete example. So let's say you have an array of names, Chris, Alex, Eva, Barry, Daniela, and what you want to do is sort these names backward. So the way you would sort a list in Swift is just do like the list dot sort by something, and after the by you have to give it a function of how you gonna sort this array. So the first example, sorting using a function, so you give a that is called a comparator. So you have to tell the you have to tell it how do you compare two elements so it can do the sorting correctly. And if you just pass in so there's a function called backward, and just pass in two strings, and then it returns a boolean, right? Because the comparator expects like a true and false for like how it's gonna sort this array. So if you have this backward function, you can just pass it into these So if you look at var reverse names equals names dot sorted by backward, so you can just pass in that function that you wrote into the comparison, the expected comparator, and then another. If you want to use a closure, the way you would do it is you can just write out the closure inside the by, which expects like a function, right? So the way you do it is reverse names equals names dot sorted by, and then you have your closure in the curly braces, which has parameters s1 and s2, and then the return type is a boolean. And then after the in, you will like put in the code that you wanted to execute, right? So that's return s1 greater than s2. Yeah.
How does that first function work? How does s comparing two strings to each other return a boolean?
Oh, it's alphabetical.
Oh, okay.
The way you compare string with the greater than or less than is like ranking it alphabetically.
Okay. So if S1 is like alphabetically before S2, it will return true.
Yeah.
Okay.
Any other question? So this is just you just don't have to write out this other function. You can just write a function inside. Because after the by parameter expects a function. Yeah. Was there a question? Okay. And then very similarly, you can also use the closure for map and filter. So if you have a list of numbers and then you want to map whether the numbers are greater than or equal to 0, you can just do list.map and the closure, which is num, num is the parameter and then returns a boolean, and you want to return if num is greater than or equal to 0. So what that does is that just maps each number in the list into a boolean of whether the number is greater than or equal to 0. Right. And then you can you also have a filter. You can also use closure and filter. Let's say you have another list of numbers and you want to filter. You want to filter out values that are not multiples of 2. So what you can do is you do values.filter and you take in a value and that returns a boolean, and then you just return value that is multiple of 2. So that just filter out the even numbers. Anyone have questions on closures? No? Okay. Then we can move into our demo today. So today's demo is basically we're gonna there's this table view with courses shown like this, and then we're gonna use SnapKit and LMOfire. Oh, also I didn't mention what SnapKit is. So SnapKit is basically another library that helps you make constraints. Just making constraints a lot easier, and you'll see how. So the first thing is normally if you create a project, you will have this you have your code and then like it has the Xcode project file, and then we want to add a path file to this folder. so we can add all the libraries that we want. So if you go to your terminal, you want to navigate into this. Well, first you needed to have installed cocoapods, but if you didn't, that's okay. You can do that afterward. But if you want to make a pod file inside this project, you have to navigate into this folder, and then are people familiar with CD? The CD command. So the CD just like navigate into whatever folder you're going to. So mine is on my project is in desktop. So I'm just gonna okay. And then once you're inside, or if you're not familiar with CD, an easy way is you can just drag that folder in, and then you'll get into the the right folder in your terminal. So inside your project file, folder, you have to do pod init. Okay, so after you do pod init, you should get this pod file inside that folder. And then you can open that pod file where it says pods for the L6 starter. Under that, you would put your all the pods that you need. So the way you do that is you say pod, and then pod, whichever pod you're gonna use. So we're gonna use SnapKit, and we're gonna also use Fire, and then save this file. Okay, so once you have this pod file on the terminal, you would do pod install. So what pod install does is it's gonna install all of the pods that you indicated on your pod file. So that's gonna install SnapKit and Fire. Right, so you have to do pod install. Anyone need more time to do this? Okay. And then you will see after you did that, there's a new. So normally we've always used Xcode Proj, this one, but this one is not gonna work with the pods that you installed. So what we're gonna use today is the L6 starter XC workspace. So if you use CocoaPods, always make sure you open the XC workspace file. So I'm gonna open that. Are we good? Here. Does anyone have questions at this point? Okay. So the demo code today is pretty, it's pretty simple. You just have a table view that's displaying a list of courses, and you have a course class that's name, co-instructor, enrolled. And then you have like the course table view cell here. So the first thing we're gonna do today is how you will use SnapKit. So the first thing you have to do is on the top where there are the imports, you will want to do import SnapKit. So you have to do the import so you can actually use what SnapKit offers. Okay. And then so SnapKit helps you set up constraints easier. So we're gonna get rid of how we have traditionally set up constraints. And let's do how SnapKit helps with that. So instead of doing all the like nslayout.activate, with SnapKit you can do table view .smp .make constraints. So you can see that the make constraints takes in a closure, right? So it's just expecting a function of how you're gonna make your constraints. So if you just click if it's highlighted and then you just click enter, it's gonna like set it up in the closure form for you. So make is the parameter, and make is a has type closure maker. I mean not closure constraints maker. So it's just how you're gonna make your constraints. That's a parameter that we've seen like for closures. And then after the in is where we put our code, all the code logic that we have. So the way you can make constraints with SnapKit is you do make dot. So for the table view we have the leading and trailing equal to the views leading and trailing. And then we have the top and bottom is equal to view safe layout guide, right? So if we want to set up the table views leading and trailing, we can just do make.leading.trailing. So the nice thing about SnapKit is you can make a few constraints at once together. So you can do make.leading.trailing equal to super view. So what that does is it's gonna make the leading and trailing of this table view equal to the super view, and the super view is this view controller. Because table view, you added view. Table view is a subview of view. So this equal to super view just means it's equal to the super view of table view, which is view, it's leading and trailing. And then to make the top and bottom anchor equal to view safe layout guide, you can do make.top.bottom equal to view.save layout guide, save area layout guide. So this is a lot simpler than having to do this. Yeah.
Could you just make them all equal to safe area layout guide?
You could. Yeah, you technically could, because view safe layout guide, the leading and trailing is the same. But there's like you can definitely do that. Leading, trailing, right? So you can put all that in one line, but there's an even easier way to do all the 4 edges. You can just say make.edges equal to views safe layout guide. So 1 line compared to 4 lines, which is nice. I'm gonna just move it back. Yeah, does this make sense? A lot easier, right? Yeah. So that's the power of having libraries. You save a lot of nasty code. And then we can do the same in course table view cell where another important thing. With SnapKit, you don't have to do table view trans auto sizing mass into constraints. Because this is really annoying, right? Like every time you have to do this, and if you forget, your thing doesn't work. So with SnapKit, you don't have to do that anymore. And then we're gonna go. We can also do the same thing for the constraints in the cell. So we can try doing that for the name label. So we're gonna do name label .smp .make constraints. So we want to make the leading equal to the super view, right? That's equivalent to name label .leading anchor .constraint equal to content view .leading anchor. So you just want to make the leading equal to the super view leading, because name labels super view is basically content view, because you added name label as a subview to content view. And then you can do name label dot make dot top dot equal to super view dot. So the way you add padding is you do dot offset, and then that gives you, and then you can pass in your padding. And then for the height, you can just do make dot height dot equal to some number, which is name label height. Anyone have questions here? No. Okay. And then the way you would do constraint, if it's like relative to another view, is so let's do it for the course number label. So the leading is equal to name labels trailing with some padding. So we can do make dot leading dot equal to so it's gonna be equal to name labels trailing. So the way you access like name labels trailing, you would do name label dot smp dot trailing. So that's gonna give you, so that's equivalent to saying name label dot trailing anchor. And then the way you add padding is, again, you add the offset. Yeah, but that's just how you would set it if it's relative to another view. And then you can do the same thing for like the trailing, the top, and the height. But I'm not gonna finish it here. Comment that out. Okay. Yeah, so that's how you would use SnapKit. Makes making constraints a lot easier. And then the next thing we're gonna use is Elmofire. So actually, how you get how you make requests and get things from the internet. So today, the thing we're gonna get from the internet is this JSON here. That's just like a list of classes from the internet that a past instructor, Mindy, made. So if you look at the starter code, there's a file called network manager, and then usually when we, so network manager is basically a file. It doesn't have to be called network manager, but we just called it network manager. It just you want to have somewhere to put all the network requests that you're gonna make in one place, so it's just nicer. So we're gonna make a class called network manager. And then this class is where we're gonna write all our requests to the internet. So first we're gonna actually also import Elmofire here, because that's what we're gonna use. And then the endpoint is just the whichever website you're trying to access, and we call that endpoint. This was the page I was showing here. So we can move this endpoint into this class. So this is gonna have an endpoint, and then I'm gonna make this this variable static. Does anyone know what static means when you make a variable static? Okay, it's okay if you don't. So what static means is just you can access this variable without initializing a network manager, object. Without initializing a object of network manager. So normally, if you want to like access something for a class, you have to do like let network manager equal like network manager, right? That's how you like initialize a network manager, and then to access endpoint, you do like nm dot endpoint, right? That's how you would, if it was just let, then that's how you access endpoint. But if it's static, you don't need to initialize a instance of network manager to access endpoint. So you can just simply do network manager dot endpoint. So yeah, it just so you don't have to make a instance of network manager to access this field. Does static make sense? Okay. And then we're also gonna make so we're gonna write the function to make the request to this endpoint. And then we're gonna make a static function so we can access it without making an instance of network manager. And this is, we're gonna call it get courses. And inside this get courses, so we want to get all the courses from this function, right? And the way we want to make a request to that endpoint, and the way we're gonna do it is with the help of Elemofire, and we can make a request doing AF. AF is just for the Elemofire dot request. We're gonna use this this wait, it's not this one. Request. Oh yeah, it is this one. So it expects the first thing that it expects is the link to whichever website you're trying to make a request to. So you can pass an endpoint, and the method. So we talked about the three methods we're gonna use, right? It's either get, post, or delete. And here we're just making a get request because we're just trying to get all the classes from that website. So this is, it's an enum, so we just access it with dot get. And then we're not gonna use all of the other things here. That's all we need. The endpoint and the method you're requesting. And then the next thing it's gonna do is dot validate. What dot validate does is, if you can read what it does. So it basically validates that the response has a status code in the acceptable range of 200 to 299. So you just make sure that validates the response that you get. And then what you do is, after you validate, you do dot response JSON. Because what it's doing here is it's gonna get a response and it expects a JSON that we're getting. And then again, this is also another closure inside. So if you enter, like, it puts it in the JSON form, and then the parameter that you're gonna get is the response. We can call it response. Oh my god, sorry, I can't spell today. And then after, so after the in, right, it's the code that you're gonna execute. So this response here is the response that you get from this request, this GET request, and we want to use that response to do whatever that we need. So the result that you get from the response is stored in response.result. And if you look at the type of result, it's a result, and result is an enum. So what can we do with an enum? Take a guess. What are we gonna do with this enum? Did I hear switch? I thought I hear switch. Okay. Yeah, we're gonna switch on this enum. I can spell, sorry. Switch. So result has the enum is either a success or a failure. So success means the result is you successfully got the data from that website, and then failure just means you got an error, right? So then we can switch on the case. So we have a case.success. And then you see that this enum actually has an argument. And the argument is the data that you actually got from this successful response. So the way you would get that data back is you say let data. And what that does is whatever successful data that you got is going to be assigned to this data variable. And then what we can do is we can print out what the data is. And then for the other case, we have a case failure. And then you see that it also has an argument, right? That's an error that has type this error. So we can also do let error. And that's gonna like give us the error that we actually got. And then we can print out the error. Okay. Does this part make sense? Okay, yeah. So that's just how you can use LMMoFire to make a GET request and get some response. So let's actually use this GET courses function. So we can go back to view controller. And you can see in view controller there's a function called GET courses, and then we can call the network manager's GET courses here to get all the courses. So you can do network manager.get courses. So here it will just call on this function in network manager, and that's gonna make a GET request to this endpoint. Yeah. Does this part make sense? Great. And then in view did load, we also call on GET courses. And then so that just means we're gonna make this call to get courses when the view loads. It's just gonna call on the network manager's GET courses. So we can try and see what we get from this. It's taking its time. Which one? Okay, yeah, so you see that it printed out this list of classes that we got from that website. This is because when the view loaded, we make a call to get courses, and then get courses is making a call to network managers get courses. And in network managers get courses, we make a get request to this endpoint, and then since we got our data back, that means it went into this case, and it printed out the successful data. And then, so this is we're just like printing, so today we just printed out whatever we got, but next week we're gonna see how we can use these, the data we get and actually display it on the app. But yeah, this is the demo. This is it for the demo. But we do have some very important action items. So this Sunday, there's going to be a hack challenge project idea submission. That's going to be, so you just basically, you just say like what kind of idea you have for your hack challenge. And if you didn't know, hack challenge is your final project, and you're gonna work with like backend members or design member, well, backend and or design members to make this this app together. And you must do it because it's your final project. And but yeah, this Sunday, the project idea submission is due. So you just basically say like what kind of idea you have for hack challenge. It's gonna be, I'm gonna post the link. It's gonna be a Google form. I'm gonna post the link on CampusWire, and I also post the link on the CMS submission. You don't submit on CMS. You just like submit the Google form, and then next Monday, really important next Monday, after lecture at 8:35, after iOS lecture, it's gonna be the hack challenge kickoff. So it's the time where you can find your group members. So all the like the backend course and Android course and maybe design course members will come to the kickoff, and you can find your teammates there. And then there's no I guess project due this week, but there's an actual credit if you want to do it. It's on closures, and it's a playground. You just like kind of we have some prompts, and then you just kind of fill it out. That's also due this Sunday. And then also make sure to set up cocoapods and install Animalfire if you want to follow along next lecture. Wait, yeah.
How big are the groups for the hack challenge?
It's 4 to 5 people.
Okay. Is
Yeah.
that just an app dev thing then? Or not just app dev, but like...
App dev courses thing.
Yeah.
Yeah.
Oh,
So you just like work with people in other courses.
okay.
You have to have front end members and back end members. Yeah, you can't just have like a 4 group of iOS members.
No.
Yeah. Yeah, what was your questions? Yeah.
For the extra credit,
Uh-huh.
we just work on the pipeline how we attach on the website.
Yeah.
Okay, we just submit that same file with them.
Yeah, like you download the file and then you fill the questions and submit it on CMS with that file.
In that same file.
Yeah.
So for the groups, you can have, as long as there is front end and back end, you can have any distribution.
Wait, there is a specific distribution, right?
I think it's 2 front-end devs most and 2 back-end devs most at most.
Yeah.
Two front end, two back end.
They'll probably clarify more at the kickoff. I don't remember the exact numbers. Yeah.
Is the idea submission thing binding, or like how?
Binding is not binding at all. The project idea is not binding. It's just like, I guess you can you don't have to decide until on a project until you have your group. But this is sort of like you have to submit it. Well, you have to submit it, but it's not binding. And you can change it later on. But this is kind of to get an idea of, well, you can form your group better because you can see like what other people have similar interests as you. Yeah. Yeah, here. Right after lecture on Monday.
I think if you
Yeah. So you would just partner with backend and design, but not Android. Yeah.